Okay guys, so next we have to discuss the cell representation. Okay, cell representation, which means how to represent a galvanic cell in a single line. Okay, for that the general pattern is first of all you have to show anode. In a galvanic cell we know that there is an anode which is dipped in an anode electrolyte followed by a salt bridge, then there is a cathode electrolyte, then there is a cathode. So that is the order. First of all you have to write anode, then the electrolyte of the anode, which having a concentration, let it be C1. If you know the concentration, then it is okay. If it is not able to know you, then you simply put it as a C1. Okay. Then this represents salt bridge. Okay, followed by cathode electrolyte. Cathode electrolyte followed by cathode. Okay, so the concentration of cathode electrolyte, let it be C2. If you know the concentration, then you can write it. If it is unknown, then put it as C2. Okay, fine. So this is a general way of representing a galvanic cell. Okay. For example, I have Daniel cell. How I can represent the Daniel cell? We know that the anode in the Daniel cell is zinc. So the electrolyte is Zn2 plus ion. If the Daniel cell is in a standard condition, the concentration will be 1 molar. If it is not in a standard condition, then the concentration will be C1 molar. Okay, followed by the cathode electrolyte, that is Cu2 plus. Then the cathode, that is Cu. The concentration of Cu2 plus is C2. Okay, so this is a representation, cell representation of Daniel cell. Fine. That's all. Now, you want to find or you want to study how to write a cell reaction using a cell representation. How to write a cell reaction using a cell representation. Okay. So, if you are given with the cell representation, then how can you show the cell reaction, overall cell reaction? Okay. For that, first of all, if I have a reaction, Cu bar means a cell representation Cu bar Cu2 plus followed by Ag plus bar Ag. Okay, so how I can write this, or how I can show the cell reaction of this one? For that, first of all you check that how much electron lost in anode. Yeah, that is 2 electron, right? From 0 to plus 2 electron lost in anode, right? And how much electron gained by silver? From Ag plus to Ag means a gain of 1 electron. So it is not possible in the case of reaction. Why? If a species lost 2 electron, then in the reaction, another species should gain 2 electron. Okay, so which one you have to put before the reaction and which one you have to put after the reaction? That is the only question. Ready? So you should choose a one component from anode and one component from cathode. Okay, you should choose a component from anode and a component from cathode. Then which species you have to choose from anode means before the reaction you have to choose a species which is to be oxidized. A species which is to be oxidized. So let's have a check. Cu2 plus is already in the oxidized form. So Cu have to oxidize. So you have to choose Cu. And from anode, you have to choose a species to be reduced. A species to be reduced. Here silver is already in the reduced form. 0 form means it is already in the reduced form. There is no minus form in case of metal, right? Yeah. So silver, it is in the zero form, which means it is already in the reduced form. So the form which I have to reduce means Ag plus. Okay, the form which I have to reduce means Ag plus. So Cu plus Ag plus gives the another. We already choose Cu from here and Ag plus from here. Then the reaction proceeds. Then the others. Others means from here there is the Cu2 plus. From here there is the Ag. But I already told you that you have to multiply a 2 along with your Ag. Then only the reaction will be okay. So this is how you can write a reaction using cell representation. Is it okay? I'll give you another example. Listen here. If I have Mg bar Mg2 plus, okay, Cr3 plus bar Cr, this is the reaction. Okay, first of all, you have to count how much electron lost, 2. How much electron gained, 3. So this is not okay. So you have to multiply, you have to make it same. For that, you have to multiply this 2 with the 3, then it becomes 6. And you have to multiply this 3 with the 2, then it becomes 6. And the trend for writing the reaction is, you have to choose a species which is to be oxidized. That is your magnesium. And in front of magnesium, 3 is required. And you have to choose a species which is to be reduced from your cathode. That is your Cr3 plus. In front of your Cr, there will be a 2. Then the rest. Then the rest means there will be 2 Mg2 plus plus 3 Cr3 plus. I'm sorry, 3 Mg2 plus plus 2 Cr3 plus. This is our oral reaction. Okay, fine. So the next cell representation, let it be Pt. If it is your she, Pt H2 bar H plus double slash, and let it be your copper Cu2 plus bar Cu. Okay, ready. So how much electron involved? It is 2. Hydrogen from 0 to plus 1, which means 1 electron. But here already 2 hydrogen is there. Here is the requirement of 2. Okay. So anyway, here already 2 hydrogen present, right? But here only 1. So you have to write 2 while you are writing H plus. Okay. Actually, the electron last is 2 electron, not out. Because H2 become 2H plus. That is the case. And the gained electron is also 2. So it is already okay. So no need of multiplying with any other kind of numbers on writing the reaction. But you have to check that, or you have to ensure that your both hydrogen will be 2. Since it is 2 here, here should be a 2H plus. Okay, fine. Listen. Then how can you write the reaction? A species which is to be oxidized, that means hydrogen. And from cathode, a species to be reduced, that means Cu2 plus. And that will be H plus plus Cu. I already told you that. You have to write 2 here. Then only the hydrogen will be okay. So this is our oral reaction. Ready? Now, here to here, 0 to minus, that is the gaining. That is 2 electron. Because since there is 2 bromine, a bromine can gain 1 electron. A bromine 0, when it gains 1 electron, it becomes Br minus. But here also, here already 2 bromines are there. So this will be a 2. Anyway, the net electron transfer is 2. Okay, so no need of multiplying with any other kind of number. Then how can you write the reaction? You have to choose a species to be oxidized, no doubt, that is copper from here. From the cathode, you have to choose a species to be reduced. That is not Br minus. Br minus is already in the reduced form. The species to be reduced means that is your bromine, Br2. So Cu auspicious to oxidize, Br2 auspicious to reduce. Then it becomes Cu2 plus plus Br minus. Already told you that here there is 2 bromine, so here will be a 2. Okay, fine. Then the next case, that is a PT. Here will be a PT, okay, because bromine also a gaseous electron. PT Cl2 bar Cl minus double slash Au3 plus bar Au with the gold. Fine. What will be the rank? Here we know that a chlorine can lose 1 electron, which mean the loss of electron is not to the right. Loss of electron from here to here. Cl minus losses electron to become Cl2. Anyway, because this is anode, losing of electron, right? If Cl minus loses 1 electron, then it becomes Cl0. But here is Cl2, so there will be a 2 electron loss. Okay. What about the gain of gold? Gold which gains 3 electron per gold. So you have to make it same. Okay. So this with the 3 and this with the 2. Okay. Fine. So the reaction will be a species to be oxidized. Species which is to be oxidized means that is Cl minus. And actually there is 6 Cl minus, right? Yes. 6 Cl minus. Because already there is 2 chlorine. So there will be 2 Cl minus. In addition to that, for making the electron same, we already multiplied with 3. So there will be 6. So species which is to be oxidized means Cl minus. So on making the coefficient same, it will be 6 Cl minus. And species to be reduced from here, that is your Au3 plus. And that become what? 3Cl2 plus 3Au. Okay, this will be the reaction. So you want to know how to write the reaction if any kind of varieties of electrodes are given. Okay, if any varieties of electrode representations are given, you should know how to write the cell reaction. Then only the next part will be okay. Okay, so I'm moving to the next part. That's all about the cell representation. So the next part, that is Nonstick question. What it is? Nonstick question. Ready? So Nonstick question means that is an empirical relation. There is an empirical relation between electrolytic concentration and electrode potential. Okay, there is an empirical relation between electrolytic concentration and electrode potential. Nonstick question. Nonstick question. Okay. The nonstick question means that is an empirical relation between electrode potential and electrolytic concentration. Relation between electrode potential and electrolytic concentration. That is said to be Nonstick question. Okay, so Nonstick question is the relation between electrode potential and electrolytic concentration. Ready? So first of all, you have to know what is the Nonstick question for electrode potential. Nonstick question for electrode potential. Electrode potential is otherwise the reduction potential, you know. Yes. So the Nonstick question for Mn plus bar M. Okay. Consider a reduction reaction. Mn plus N electron gives M. So let it be a reduction reaction, just like your Zn2 plus 2 electron gives Zn, like that. Okay. So this be a reduction reaction. Okay. And what is the reactant here? The reactant is Mn plus. And the product is M. M is a pure metal, right? Yes. Then the Nonstick question for electrode potential of this one, for this reaction, the electrode potential will be Mn plus bar M, which means reduction potential or electrode potential. For finding the electrode potential, you have to know, first of all, you have to know what is the standard potential. That standard potential may be given in your question, and it is already determined using with the help of She, we know, and it is sorted in your electrochemical series. Okay. So for finding electrode potential of any electrode which is dipped in any concentration, any kind of concentration, You have to choose the, first of all, you have to choose the standard electrode potential of that typical species. Then you have to add a 0.0591 by n. 0.0591 by n log. What is n? N is the number of electron involved. N is the number of electron involved. Log the concentration of Mn plus divided by the concentration of M. Okay. But for any solid, its activity is simply taken as 1, right? Yes. So log the concentration of Mn plus. Ready? Or we can write this equation in this form. E Mn plus bar M is equal to E0 Mn plus bar M minus 0.0591 by N log concentration of M divided by concentration of Mn plus. Well, the concentration of M simply taken as 1, okay? Ready? So the logic is this much. If there is a plus sign here, then your expression where the log have a ratio between reactant and product. What? Reactant and a product. If there is a plus sign, then the log ratio will be reactant to product, right? Mn plus is a reactant and M is the product. Or if it is a minus sign, then the log have a ratio of product to reactant. Okay. So anything may be in your question. It may be, the form may be like this or like this. Okay. So the simple logic is this much. If there is a plus, then the reactant by product always. Minus product by reactant. Okay. Fine. Keep it in mind. For example, okay, if I want to find the electrode potential of Zn2 plus bar Zn, how much? Okay. If standard electron potential of this one is given, you want to find the electrode potential of Zn2 plus bar Zn. If its standard electrode potential from electrochemical series is given as minus 0.76, okay, and the concentration of Zn2 plus is simply 2 molar, okay. So what will be the electrode potential? We know that E Zn2 plus bar Zn is equal to E0 Zn2 plus bar Zn. Mn plus bar M is equal to E0 Mn plus bar M plus 0.0591 by N. N is 2 here, right? Yes. Log the concentration. Since there is a plus, this is a reactant Zn2 plus, this is a product Zn. So log reactant by product. So log Zn2 plus concentration divided by Zn concentration, right? Yes, Mn plus by M, since there is a plus. And the Zn2 plus concentration is 2, and this is simply taken as 1. Okay, so this value will be minus 0.76. For your objective examination, simply this is taken as 0.06 divided by 2 into log 3. Sorry, log 2. So the value will be minus 0.76. This is cancelled, 0.03 plus 0.03 into 0.3, right? Log 2 the value is 0.3. I think you are familiar with that. Log 2, the value is 0.3. So 3 into 0.3, that will be 0.03 into 0.3. That will be 9 into 0.009. 0.009, right? Yes. So answer will be minus 0.76 plus 0.009. So the final answer will be so if you wanna less 0.7600 minus 0.009, right? Yes. 1 5. Ready? And this is 7. 0.751 minus 0.75. Okay, ready? This will be the answer. Okay, so you have to know the values of log for this one. I think you are familiar with the values of logarithm. Okay, I'll give you the values. minimum you have to study this much. That is log 1, log 2, log 3, log 4, log 5, log 6, log 7, log 8, log 9, log 10. Log 10 is 1, log 9 is 0.95, log 8 is 0.9, 7 is 0.85, actually 0.984, simply approximately 0.85. This is a class, but the difference is between 0.05 and log 6 is 0.8, 5 is 0.7, 4 is 0.6, 3 is actually 0.3747. You choose it as 0.5. Okay, and this is a class, but the difference is 1. And log 2 is 0.3 and log 1 is 0. So there are a lot of numbers here. Log 1.2, 0.1, log 1.4, 0.15, log 1.6, 0.2, log 1.8, 0.25. Okay, 0.25. So minimum this much is required. Okay, minimum this much is required. So you have to study this in a section wise, then it will be more easy. Ready? Okay, so moving to the next Nernst equation. That is the Nernst equation for cell potential. Nernst equation for cell potential. Okay, ready? So copy this. Nernst equation for cell potential. Okay, so for finding the Nernst equation for a cell potential, you have to write the reaction where reactant turns to product. Okay, then the expression for Nernst equation for the cell potential of that reaction. Cell potential for this cell reaction will be E cell is equal to, just like the previous case, E cell is equal to E0 cell plus 0.0591 by N. Since this plus log the concentration of reactant to the concentration of product. So the ratio is still remains same, just like your expression in your electrode potential. Okay, so this is a general expression for cell potential. Ready? And how can we show one example? Listen here. If I have a cell potential, a cell representation Al3 plus bar Al3 plus, which gives Zn2 plus bar Zn. This is a galvanic cell. Okay, how can I write the expression for cell potential? First of all, you have to identify which is reactant and which is product. For that, you have to show the reaction. Okay, for writing the reaction, we already know that how it can be possible. Here the dropping of 3 electron, here the gaining of 2 electron. Okay, so it is not equal right now. So you have to multiply 2 here and 3 here. And you have to choose a species which is to be oxidized. That means Al or Al3 plus. The species to be oxidized is Al. For Al, there will be a 2. Okay, and species to be reduced. Reduced means Zn2 plus. And before your Zn2 plus, there will be a C, 3. Which gives what? Al3 plus, how much? 2. Zn how much? 3. This is a reaction, right? For the reactants, this is a pure metal. For the concentration taken as 1. This is also pure metal, concentration taken as 1. So the reactant is Zn2 plus, and the product is Al3 plus. So I'm okay with the reaction from your cell representation. Then the equation is E cell is equal to E0 cell plus 0.0591 0.591 by n. What is the n here? N, 3 into 2. The total number of electron involved is 6. Fine. Log the concentration of reactant divided by the concentration of product. Okay. So you have to choose which is reactant and which is product. And it is from your cell reaction. So which one is the reactant? Yes. Zn2 plus. Since there is a 3 stoichiometric coefficient, you have to raise it with the Zn2 plus. I think you are familiar with that. Okay. On writing the expression for reaction quotient, if there is any kind of stoichiometric coefficient, you have to raise it with that, right? And the product is Al3 plus. Agreed. The coefficient is 2. This is the expression. How can you find the E0 cell? It is using the relation E0 cathode minus E0 anode. Which is the cathode here? Which one is the cathode? That is cathode part is zinc. So E0, the electrode potential of zinc minus anode part is aluminum. Electrode potential of aluminum. Okay. So this is how you can find the E0 cell. And the rest, if the values of Zn2 plus and Al3 plus are given, the concentration of Zn2 plus and Al3 plus are given, and you can find the whole value, then you obtain the cell EMF. Okay. So this is an indication for finding the EMF of a cell. Ready? Ready. So we are moving to the third Nonstick question, that is the Nonstick question for equilibrium constant. The Nonstick question for equilibrium constant. Okay. Nonstick question for equilibrium constant. Fine. So the third Nonstick question for equilibrium constant. Equilibrium constant. That is for K. Okay. The expression is nothing but it is very easy. The expression is actually for log K. Log K equal to N E0, N into standard EMF divided by 0.0591. Actually, the 1 divided by 0.0591 is approximately 17. Actually, it is 16.99. So you can simply approximate it as 17. Okay. It is nothing. 1 divided by 0.0591 is approximately 17. So this one will be equal to 17 N E0. So this is the expression for calculating the equilibrium constant from the Nonstick question. And actually you are asked to find the K value. How can we find the K value? K value is the, if log K and if it is raised by a 10, then you obtain the K value. Okay, so this is an Nonstick question for what? Nonstick question in case of equilibrium constant. And I think you are familiar with the sparingly soluble salt. Sparingly soluble salt. And the case of sparingly soluble salt will be discussed in detail in your equilibrium. For sparingly soluble salt, actually the equilibrium constant, equilibrium means equilibrium. Equilibrium constant replaced as solubility product constant. Equilibrium constant, instead of equilibrium constant, you can define the term solubility product constant. I think you are familiar with that. Else, it will be discussed in your equilibrium. So, what will be the expression? Log, in case of sparingly soluble salt, log of the solubility product, log of KSP will be N E0 divided by 0.0591. Nothing. Your K is replaced by KSP, which is equal to 17 N E0. Ready? So this is expression for calculating the solubility product in case of sparingly soluble salt. Okay, so this is an Nonstick question. Ready? Then the next equation, the next equation is for Gibbs energy change or free energy change. I think you are familiar with the free energy change in your thermodynamics. Okay, so the next equation for free energy change. For free energy change, delta G. Delta G. Actually, the expression delta G equal to minus NF E. Minus NF EMF. Minus NF E. Or if it is in a standard condition, then delta G0 equal to minus NF E0. Minus NF E0. Ready? This is the expression. F, you know, F is Farad constant 96500. Okay. Ready. And one more thing you have to know, that the constant 0.0591, which is actually obtained by the multiplication of 2.303 into 8.314 into 298 RT by F divided by 96000. Okay, by multiplying, dividing these numbers, then you obtain the value 0.0591. Okay, so simply remind it. Okay, the 0.0591, the constant which is used in the Nonstick equation, that is actually derived from or obtained from the multiplication division of these all values. 2.303 into 8.314 into 298 and 96500. And I think you know that 96500 is Farad constant. 2.303 is the constant which is used for changing the base of log, right? And it is used for changing the base of natural logarithm to common logarithm. And 8.314, you know the value of gas constant. 298, the temperature in your equilibrium, standard temperature in your electrochemistry. So if you are multiplying or dividing with all this value, you obtain the 0.05. So the expression for delta G is delta G equal to minus NF is minus NF E. E means the EMF of that cell or E cell. N is the number of electrons involved in that reaction. F is the Farad constant. Okay, but listen here, listen. If I have a reaction, Ag gives Ag plus plus 1 electron. Ready? And 2Ag gives 2Ag plus plus 2 electron. Which means this reaction is multiplied using 2, right? Yes. Then, what about the EMF of this cell? Its EMF still is E0. Its EMF is E0 here. Here also, the EMF remains as E0. But here the number of electron involved is 1, but the number of electron involved is 2. The value of E or E0, that did not depends on the number of electron involved, but the value of delta G, that depends on number of electron involved. So therefore, the delta G, if the delta G here is delta G0 in the first reaction, then in the second reaction, the delta G will be 2 times of that delta G0. Okay. So if a reaction is multiplied using the using N, then the delta G will be multiplied with the N, where the EMF of the cell or standard EMF of the cell remains same. Okay, that is one point that you have to keep in mind. That is, electrode potential is a intrinsic property which do not depends on the operations. Ready? That depends on the electrode and electrolyte. Okay. Whereas delta G, free energy change, is an extrinsic property that depends on the changes in the expression, or that depends on the reaction and number of electron involved, like that. Okay. So that is one of the point. And the most important property from this Nonstick question, that is, if I have a cell reaction, let it be cell reaction number 1, where the electron involved in this cell reaction is N1 and the potential of this cell reaction is E1. Potential of this cell reaction is E1 and the free energy of this cell reaction is delta G1. Okay. So I have a cell reaction. Let the cell reaction have a name of 1 and the number of electron involved in this cell reaction is N1 and the EMF of this cell reaction is E1 and the free energy change in this cell reaction is delta G1. Okay. Okay. Are you okay? Fine. I have one more cell reaction. Let it be cell reaction number 2, where the number of electron involved in this cell reaction is N2, EMF of this cell reaction is E2, and delta G of this cell reaction, let it be delta G2. And I have one more. Let it be the cell reaction number 3, where the number of electron involved is N3, cell potential is or electrode potential is E3, free energy change is delta G3. Okay, fine. If you know that cell reaction 3 is obtained, the reaction number 3, which is obtained by the addition or subtraction, whatever it may be, it is obtained by the addition of cell reaction number 1 with the cell reaction number 2. Ready? If the cell reaction number 1 and cell reaction number 2 is added to form the cell reaction number 3, then E3 will not be equal to E1 plus E2. E3 will not be equal to E1 plus E3, but delta G3 should be equal to delta G1 plus delta G2, which means what is delta G3? Minus N3F E3, right? What is delta G? Minus NF E. So what is delta G3? Minus N3F E3. This will be equal to minus N1F E1 plus minus N2F E2, which means F is cancelled from whole. And minus is also cancelled from whole. So if you obtain a third cell reaction by the addition of cell reaction number 1 and cell reaction number 2, then you can say that N3, electron involved times of cell potential of the reaction 3, will be the sum of electron involved times of cell potential of reaction number 1 plus electron involved times of cell potential of reaction number 2. E3 will not be equal to E1 plus E2, but N3 E3 will be equal to N1 E1 plus N1 N2 E2, because delta G3 will be equal to the sum of delta G1 and delta G2. Okay, so that keep it in your mind. Okay, question may ask from here also. If there is any kind of your question, if there is any type of question from this theory in your discussion material, I'll discuss it. Okay, ready, fine. So this is one of the kind of typical property. So moving to the next. Nonstick question in case of she. Nonstick question in case of she. Okay. So in case of standard hydrogen electrode, for the reaction we know, normally the expression for electrode potential, of she, right, at any concentration. If any kind of concentration of she is given, we know that the electrode potential of she at 1 molar concentration, which means standard condition, is 0. But if the concentration changes, the electrode potential may change. Then how we can connect that equation? That is the next case. What do you mean by electrode potential? EH plus become H2. This is said to be electrode potential or reduction potential of this one, right? Yes. For that, I have the reaction H plus become what? H2. How the H plus become H2? By accepting 2 electrons. Ready? Fine. So H plus having a concentration C1 and H2 having a pressure of P1. H plus having a concentration of C1 and H2 having a pressure of P1. There is a chance for pressure also because hydrogen is a gas. So what about the Nonstick equation? We know that the Nonstick equation for cell potential is, Nonstick equation for any electrode potential is E mn plus bar m is equal to E0 mn plus bar m plus 0.0591 like that, okay? So here the expression will be mn plus bar m is H plus bar H2 PT. So EH plus bar H2 PT equal to E0 H plus bar H2 PT plus 0.0591 by N, and in case of she, the N will be 2 log the concentration of log reactant by product. The reactant is concentration of H plus, the square, divided by product is partial pressure of H2. Why the square? Since 2 is here. So partial pressure of H2 raised to 1 is required because the coefficient is 1. So this is expression, and we can say this also. This will be 0. Standard electrode potential of she is nothing but it is 0. So standard value will be 0. Then what will be the expression? Yes, EH plus bar H2 PT equal to 0.0591 by 2 log concentration of H plus divided by partial pressure of H2. This is the expression for finding electrode potential of she. Okay. If the pressure is 1 bar or 1 atm, if in the question the partial pressure of hydrogen is said to be 1 bar or 1 atm, then what will be the expression? Then the electrode potential of she will be, this one will be 1, right? Yes, will be 0.0591 by 2 log H plus raised to 2. And you know the property, log x raised to n is n log x. So this one will be 0.0591 by 2 into 2 log concentration of H plus, right? Yes, this 2 is cancelled. This 2 become here. If this 2 is cancelled, then if I am writing this one as something like this, I am simply placing a minus here. Minus 0.0591 into minus log H plus. Simply. Okay. No problem. Minus into minus become plus. Okay. So there is no change in the resultant value. So if I can write this into minus 0.0591, it is minus log H plus. We know that minus log H plus is pH. Okay. Minus log H plus is pH. So we can conclude it as, in the case of she, the electrode potential, if the pressure is 1, if the pressure is in a standard condition, then the electrode potential of she will be minus, you have to keep that minus in your mind, okay, minus 0.0591 by 0.0591 into log H plus log, into pH. Into pH. This is very important. Frequently asking question from this one, okay. Find the electrode potential of she if it exists in a pH of 3. So you simply multiply the 3 with this minus 0.05 and you obtain that. And this is a general expression. And this is the expression for she. Okay. Ready. So let me define one more expression for you, or one more logic in your Nonstick question. That is concentration cell. What it is? Concentration cell. Okay. So one more idea. Concentration cell. That also in your topic, or that also in your syllabus. Or in the case of objective examination, you have to know one more topic, that is concentration cell. So concentration cell mean a cell where anode and cathode are same, but they exist in different concentration. Okay. Cell in which Both electrodes are same. Both electrodes are same. But electrolytic concentration different. But the electrolytic concentration will be different. For example, if I have copper electrode, this is a galvanic cell, okay? Ready? Copper electrode in Cu2 plus. The same copper electrode in Cu2 plus. But the concentration of this is C1. The concentration of this is C2. Okay? Since the concentration have a difference, there will be an electron flow from anode to cathode. Okay? So, the expression for E cell, what will be the reaction? Here the reaction is, since this is anode, the reaction is Cu gives Cu2 plus 2 electron. And this reaction in anode. But the concentration of Cu2 plus is C1. Okay? And what is the reaction in cathode? Reduction. Cu2 plus 2 electron gives Cu. But the concentration of Cu2 plus in cathode is C2 and anode is C1. What is the oral reaction? Oral reaction is Cu plus Cu2 plus. Which Cu2 plus? Cu2 plus with the concentration C2 gives Cu2 plus. Which Cu2 plus? A Cu2 plus with the concentration C1 plus Cu. So this is a reactant, this is a product. Then what will be the Nonstick question? Nonstick question is E cell is equal to E0 cell plus 0.0591 by, generally it is N, log the concentration of reactant. Which is the reactant? C2. Concentration of reactant. Generally it is reactant by product. So log C2 by C1. And one more thing is that E0 cell will be 0. Why? What do you mean by E0 cell? It is E0 cathode minus E0 anode. Which is a cathode? Copper. Which is anode? Copper. So, electrode potential of Cu2 plus bar Cu minus, once again the electrode potential, both are same. So, both have same value of standard electrode potential. So, the difference will be equal to 0. So, in case of concentration cell, E0 cell will be 0. Okay. So, what will be the general final expression? E cell is equal to very same 0.0591 by N log the concentration of reactant. If the concentration of reactant is C2, then it is okay C2 divided by C1. Here, the concentration of reactant is C2. Or simply log the concentration of cathode by anode. This is the expression for expression of Nonstick question for any concentrations. Okay, ready. But one more change is that if the concentration shell is She, then there is one more change. That is the last case in this category. Okay, so concentration cell with the She, concentration shell with the She, concentration cell with the She, concentration shell with the She. So the concentration cell with the She means anode is your She, cathode also She, but the anode have H plus concentration, cathode also have H plus concentration. The H plus concentration is in C1, C2, where the partial pressure of the gas inside here will be P1, and since it is She, there will be a concentration of hydrogen inside here, let it be P2. Okay. What about the overall reaction? If I know the overall reaction, then only I can derive the cell potential. What about the overall reaction here? This is anode. Anode means H2 become 2H plus plus 2 electron. And this is cathode. Cathode means 2H plus plus 2 electron become H2. But you have to think properly. Here the pressure is P1, concentration is C1. Here the concentration is C2, pressure is P2. So what is the overall reaction? Overall reaction. Tell me. 2 electrons will be cancelled, right? So H2 plus 2H plus. H2 from here, which means H2 of P1 partial pressure. And 2H plus from here. That means H plus of C2 concentration gives, tell me, once again, 2H plus plus H2. But the 2H plus is of C1 concentration and H2 is of P2 partial pressure. So what will be the, if this is a final reaction, what will be the cell EMF expression? E cell is equal to E0 cell. There is no doubt E0 cell for any concentration cell is 0. So this is a concentration cell with hydrogen, right? Plus 0.0591 by N. Since hydrogen, the N is 2, okay. Okay. Log reactant. Reactant, which is reactant? Log the partial pressure of hydrogen into concentration of H plus the square. Let the partial pressure of hydrogen into concentration of H plus the square divided by product. Partial pressure of hydrogen into concentration of H plus the square. Okay. By having a careful looking, E cell is equal to 0.0591 by 2. What is this one? Reactant. So pH2 is P1 and H plus concentration is C2. So this is P1 into C2 square divided by P2 into C1 square. This expression. Okay. If P1 equal to P2, which is equal to 1 bar or 1 atm, which is given in the question condition, then the expression will be E cell is equal to 0.0591 by 2. Where is the log? Here is a log, right? I'm sorry. 0.0591 by 2 log, right? Yes, the log is here. 0.0591 into log P1 and P2 will be 1. Okay, or P1 equal to P2. If the case is P1 equal to P2 or P1 equal to P2, which is equal to 1, then the C1, C2 terms will be there, right? So C1 square by C2 square. Simply it is C2 by C1 the square. And you know that this 2 will be here. So 0.0591 by 2 into 2 log C2 by C1. So 2 cancelled. What happens? E cell is equal to 0.0591 by 0.0591 log C2 minus log C1. Okay. So what is C2? Concentration of H plus in cathode. What is C1? Concentration of H plus in anode. Don't forget it, okay? So E cell is equal to 0.0591. Listen carefully. This is written in the form of minus log C1 plus, minus log C1 minus. This plus log C2 is written as minus log C2. Okay. So what is minus log C1? Minus log the concentration of H plus in anode, which means pH of anode. So this is pH of anode, and pH of anode minus, what is this much? Minus log C2. Minus log C2. C2 the concentration of H plus in cathode. So minus log C2 means pH of cathode. So this is the expression, okay? Keep it in mind. In case of concentration cell, if the concentration cell is She, where the pressures are same in both cell, or the pressures are same or the pressures are unity, then if the pH at anode and cathode is given, then the cell EMF will be 0.0591 of pH at anode minus pH at cathode. pH anode minus pH cathode. Okay, fine. So that's all about the Nonstick question. Ready? Okay. So these equations you have to keep it in your mind. These all relation, the relation which are boxed in front of you, that you have to by heart very well. Okay. So let me have a summary. Summary. What is a summary? Nonstick equation for electrode potential Emn plus bar m is equal to E0 Mn plus bar m plus 0.0591 by n log Mn plus. First one. Cell EMF is equal to E0 cell plus 0.0591 by n log the concentration of reactant by product, and you have to choose which one is reactant, which one is product by looking to the cell reaction. Okay, and in case of concentration cell, and here if she then EH plus bar H2PT will be equal to 0.0591 log H plus or minus 0.0591 times of pH of that solution. Okay, if this is a concentration cell of any electrolyte, then cell EMF will be equal to 0.0591 by n log C2 by C1, log concentration of cathode by anode. Concentration of cathode by simply reactant by product, that is the logic. Okay, and reactant and product, that you have to choose from the reaction. If the concentration cell is the concentration cell, so E cell is equal to 0.0591 by n log P1 C2 square divided by P2 C1 square. If P1 equal to P2 equal to P2, or which is equal to 1, then the cell EMF in the case of she is 0.0591. Here is 2, right? pH anode minus pH cathode. Okay, you have to study that. Then the expression for log K equal to NE0 divided by 0.0591 or 17 NE0. If in case of a sparingly soluble salt, your K will be Ksp. Okay, and the last one, that is delta G equal to minus N of E. Delta G0 equal to minus N of E0. Okay, and the one more thing is that if there are two cell reaction which is added to form another cell reaction, then the third cell reaction where the product of number of electron invert times of potential will be the sum of product of number of electron times potential of the first two cell reaction. Okay, N3 E3 equal to N1 E1 plus N2 E2. These all reaction you have to keep in your these all relations you have to keep in your mind. So that's all about the galvanic cell. So we want to discuss a theoretical small section that is said to be battery. Then we can discuss the questions. Then your chapter will be over.